So we're going to have a look here now at a different type of calculation where we are looking to calculate something called molar enthalpy change from experimental results. Okay, just see popped up this equations that we're going to be using in order to help us. So if we look at molar enthalpy change, delta H, it consists of two parts. Q, which is heat energy released. So that's the measured energy released from a reaction. Okay, so we're going to be using our temperature rise and experimental data to work that out. And it's per mole, so we need to work out how much reactant we reacted. Okay, and then we put those two together, and that allows us to calculate the molar enthalpy change, so the change in energy per mole of reactant. So first thing we need to do is to calculate the value for Q. Okay, which is equal to mc delta T. So the M part is the mass of solution, which we can find here. So we can see that there was 45 cm cubed of copper sulfate solution. Okay, and for most solutions, 1 centimeter cubed is the same as 1 gram. So 45 cm cubed of solution will be 45 grams. So that's our value for M. Times by C, which is a constant value which will be given to you in the exam, which is 4.18, times by the delta T, so that's a change in temperature, which in this case is 46. And we put that all together, and that gives us a value of 8,652.6 joules, so joules of energy. So that's the amount of energy released during this reaction. So that's the Q part done. We now need to concentrate on working out moles, so how much stuff reacted. Okay, and we work out the moles of what's not in excess. So basically what was used up during this experiment. So it's a reaction of calcium and copper sulfate. And it says here that the copper sulfate was in excess. So that was not used up. What was used up was the calcium. So we're going to work out the moles of calcium in this case. And to do that, we're going to use mass over MR. So the mass of calcium is given here as 0.32 grams divided by its MR of 40, which equals 0.008 moles. So finally, we can now look to calculate our molar enthalpy change, which has the symbol delta H. So we use Q, 8,652.6 over 0.008, and that comes out at quite a big number. So currently that is in joules per mole. The question you will notice, and in most cases ask for the answer in kilojoules per mole. So to convert, we need to divide by 1,000, which when rounded up gives us a value of 1,082 kilojoules per mole. Last thing we need to do is to think, is this an exo or an endothermic reaction? You can see we've got a temperature rise, which tells me it's a exothermic reaction. So the value for delta H should be negative.